Hello, welcome to our channel. In this video, we will talk about complex numbers. We will basically introduce what are complex numbers, and we will look at some examples. We will also talk about conjugates and absolute values of complex numbers. So an imaginary number is simply a square root of a negative number. So a square root of -1 is the unit imaginary number, which is denoted by I. Basically, I is square root of -1, like we have here. So otherwise, square root of any negative number, like square root of -5, is imaginary number because it's not real. If you have square root of positive number, it's a real number. Otherwise, if we have square root of a negative number, we call that an imaginary number. If you try evaluating something like this in your calculator, square root of -5, it will probably show you an error because square root of -5 is not defined in the field of real numbers. So we call it an imaginary number. Here are some examples. We want to write these in terms of I whenever possible. So we can write square root of -25 as square root of -1 times 25. Because if you want to write in terms of I, you somehow want to have square root of -1. And then we can write this as square root of -1 times square root of 25. But square root of -1 is I, square root of 25 is 5. So I'm going to write that 5 first. And then square root of -1 is I. So this is 5I. The same thing with the second one. This we can split as -1 times 81. So this is square root of -1 times square root of 81. Square root of 81 is simply 9, and square root of -1 is I. So we have 9I. The same idea here. So we have square root of -1 times 7. So this is square root of -1 times square root of 7. There isn't much we can do with square root of 7, so we can just leave it like that. But square root of -1 is I. And the same idea with the last one. Here we have -1 times 12. So this will be square root of -1 times square root of 12. We can simplify square root of 12 because 12 is 2 times 2 times 3. So out of these two twos, we can take 1 2 out. So it will look like 2 square root of 3 and square root of -1 is I. So we have written these in terms of I. All these are imaginary numbers because you see we have square root of negative numbers, and any imaginary number we can write in terms of I. So here we have powers of I. Using the fact that I equals square root of -1, we can simplify these powers of I. So since I is square root of -1, if we square both sides of this, we get I square on the left side, and on the right side, the square root goes away. So we are just left with -1. The next one, we have I cubed. So I cubed we can write as I times I square. And we know I square is -1. So I times I square will be I times -1, which is -I. Next, we have I to 9. So this we can write as I times I to 8. So I'm going to leave I as it is, but for I to 8, I can write that as I square to the power 4. So 8 is 2 times 4. And this becomes I times I square is -1 to the power 4, but -1 to the power 4 is 1. We have I times 1, which is simply I. So I to 9 is I. Next, we have I to 10. This I can write as I squared to the power 5. So I try to write everything in terms of I squared because we know I squared is -1. So this becomes -1 to 5. -1 to 5 is -1. And again, here we have I to 54. So this we can write as I square to the power 27, because 2 times 27 is 54. So this becomes -1 to 27, because I square is -1, and -1 to 27 is -1. So similarly, we can figure out any power of I. All right, so a complex number contains a real part and an imaginary part. So if you have a real part and imaginary part put together as a sum, like a plus bi, then we call it a complex number. So a is the real part and bi is the imaginary part. They can be displayed in a complex plane, which we denote by C, which has real and imaginary axes, like this one here. So this is the real axis. The horizontal axis is the real axis, and the vertical axis is imaginary axis. So let's plot these complex numbers in this plane. We have 2 plus 3i. The real part is 2, and we have 3i over here. So the complex number 2 plus 3i is right here. We have 2i minus 10. So the real part is -10, which is somewhere here. I'm going to have to extend this. So -7, 8, 9, 10. -10 is here. So the real part is -10, and the imaginary part is 2i. So we have that over here. So this is the point corresponding to 2i minus 10. And -5i. So you see, we can write this as 0 minus 5i. So real part is actually 0. So real part is 0. The horizontal value on the horizontal axis is 0, which is right here. And the imaginary part is -5i, which is down here. So this is -5i. So this way we can plot any complex number on a coordinate plane. Next, let's look at conjugates of complex numbers. If you have complex number a plus bi, its conjugate is a minus bi, which we denote by a bar on the top. And the conjugate of complex number a minus bi is a plus bi. So the conjugate of 2 plus 3i is 2 minus 3i. Let's plot both of these on the plane here. So 2 plus 3i is right here. And 2 minus 3i would be over here. So this is the conjugate of 2 plus 3i, which is 2 minus 3i. And similarly, conjugate of 2i minus 10, we make the complex part negative. Here complex part is 2i, so it will be -2i minus 10. So let's again plot both of these. So to plot 2i minus 10, the real part is -10. So we need to extend this. -7, 8, 9, 10. So -10 is right here. So the given complex number is -10 plus 2i, which is somewhere up here. So 2i minus 10. And the conjugate is -2i minus 10. So -2i go down by 2 units at -10 on the horizontal axis. So this is the conjugate, -2i minus 10. And this last one, again, to get the conjugate, we negate the imaginary part. So the conjugate is simply 5i. So -5i is right here. And 5i is up here. So this is the conjugate of -5i. Next, let's talk about absolute value or modulus of complex numbers. So absolute value is simply the distance between 0, 0 and ab for complex number a plus bi. And that distance we can get by using this formula. So if you have 2 plus 3i, its absolute value is 2 squared plus 3 squared, square root of 2 squared plus 3 squared, which is square root of 4 plus 9, which is 13. So in the graph, the point 2 plus 3i is right here. And the absolute value represents this length, square root of 13. The distance from origin to that point 2 plus 3i. The same idea with this one. The absolute value is square root of 2 square plus negative 10 square, which will be square root of 104, because 2 square is 4 and 10 is negative 10 square is 100. So we get that as the absolute value of the second one. So on the graph, we have the point representing 2i minus 10 over here. So this length is square root of 104, which represents the absolute value of this complex number. The last one here. So here the real part is 0. So the absolute value will be 0 square plus negative 5 square, which is square root of 25, which is 5. So that means if we plot this point, negative 5i, which is over here, the absolute value of this complex number is simply this length, which is 5. All right, so this is all I have put together in this video, just a very brief introduction to complex numbers. In our next video, we will talk more about complex numbers. We will look at how we can add them, subtract, divide, and multiply complex numbers. Thank you for watching. See you in our next video.